Okay, let's talk about something we all do probably 100 times a day. Copy and paste. It seems harmless, right? Well, it turns out we're all part of this massive, hidden problem that's kind of quietly breaking our digital world. But today, we're going to look at a really cool W3C initiative that's designed to fix it. It's called Procedural Memory Knowledge Representation, or PMKR for short.
So, the core of the problem is actually super simple to grasp. Right now, our digital life is basically built on copy, paste, and repeat. Just endless copies of the same thing. But what if? What if we could flip that script entirely to a world where you store once and reference everywhere? That's the big, game-changing idea we're diving into.
And the folks behind PMKR, they have a name for this whole mess. They call it the digital duplication crisis. And honestly, that's a perfect description. Think of it like a hidden tax we're all paying on every single redundant file, every copied document, every duplicated piece of data floating around our systems.
And believe me, the costs are very real. First off, you've got this massive data bloat, which costs a fortune just to store. But here's the really scary part. When you have multiple copies of something, they always drift out of sync. Always. And that creates these huge risks for things like compliance and just basic operations. It is a total maintenance nightmare that drags down everything from performance to security.
Okay, so what's the fix? Well, a new W3C community group has stepped up to tackle this problem head-on. And their solution is a whole new way of thinking called Procedural Memory Knowledge Representation. Yeah, PMKR. And they have this brilliant way of describing it. Just think of it as a symlink for knowledge.
So what is PMKR really? Well, it's a completely different way of looking at information. Instead of treating knowledge like static data, a dead document, it treats it as an executable procedure, something that runs. The idea is you store it just one time, and then everywhere else that needs it just uses a tiny, lightweight reference to call it. It's a huge shift, moving away from duplicated documents and towards what you could call executable infrastructure.
And that symlink analogy just nails it, doesn't it? If you've ever messed around with a command line, you know exactly what a symbolic link is. It's not the file itself, it's just a tiny pointer to the real file. So instead of copying that massive file 1,000 times, you just create 1,000 tiny little pointers. PMKR basically takes that beautiful, elegant logic and applies it to, well, all digital knowledge.
Okay, that's the what. But how does it actually work under the hood? Let's get into the nitty-gritty and look at the architecture that makes this whole thing possible.
The whole thing is built on a 4-layer architecture. Think of it like building with Legos. You start at the bottom with the form layer. This is the most basic shape, like the visual glyph for the letter A. Then you snap on the meaning layer, which says this shape means the sound ah. On top of that, you add the rules layer, which has executable logic. And finally, you have meta rules at the very top, which are like strategies that control the rules below. But here's the magic. Each layer just references the one below it. It built up all this complexity without ever copying the original data.
Now, this brings up a really important distinction. You see, most of our current systems, like RDF or OWL, are declarative. They're all about the what. They describe facts and relationships. PMKR, on the other hand, is procedural. It's all about the how. It gives you runnable instructions. And it's not trying to replace those other standards. The folks behind this are super clear. We still need that declarative what. PMKR just adds the missing piece of the puzzle, the execution layer on top.
So, the big question, how does this stack up against the AI we hear about every day, like LLMs? Well, when you look at explainability, it's night and day. An LLM is basically a black box. It gives you an answer and says, trust me. PMKR is totally transparent. It says, here's exactly how I calculated that, step by step. And the size difference? It's just wild. We're talking about a tiny, super efficient 7 million parameter core for the reference implementation compared to LLMs with hundreds of billions or even 1 trillion parameters.
All right, I know what you might be thinking. This all sounds fantastic in theory, but does it actually work in the real world? And the answer is a big, emphatic yes. Let's look at the proof, which comes from a real-world project called Knowledge3D, or K3D for short.
So the single biggest headline number to come out of the K3D project is this: roughly 70% data compression. And just to be clear, that's not some pie-in-the-sky projection. That is a real measured result. And let me give you a concrete example of how they did it. The K3D project has this thing called the character galaxy. They took almost 88 megabytes of raw font data and squashed it down to just over 26 megabytes. How? By storing each character,
Every letter, every symbol, only once is a little procedural program. The letter A exists one time, and it's just referenced over and over again. It's so simple, it's brilliant.
But it's not just about saving space. The performance metrics are just as impressive. The K3D implementation has a median query latency of 42 microseconds. I mean, that is blazingly fast. It also runs with what they call GPU sovereignty, which basically means it has no external dependencies that could slow it down or introduce security risks. And because everything is a step-by-step procedure, every single calculation is fully auditable, right from the beginning to the final answer.
Okay. So let's recap. We have a huge problem, the duplication crisis. We have an elegant solution, PMKR, and we have a working proof of concept, K3D. So what's next? Well, the next logical step is the path to standardization. It's all about taking what they've learned from K3D and turning it into a real open web standard that everyone can use.
And this whole effort is being spearheaded by what they call a triple foundation of experts, with each person bringing a crucial piece of the puzzle to the table.
So you have Daniel Campos Ramos, who's the architect behind that K3D implementation we just talked about. Then there's Milton Ponson, who handles the deep mathematical and declarative foundation. And finally, Christoph Dorn, who's focused on the sovereignty and the overall framework to make sure this can be a truly robust global standard.
And they have a very clear roadmap. The community group just launched in February of this year, 2026. They're already moving on a draft of the core spec, planning to get community feedback, and aiming to finalize a version 1.0 by the end of the year. And of course, there's a whole plan for 2027 to build out things like conformance tests.
So let's pull back for a second and ask the big question. Why does any of this actually matter? Because the implications of having a single procedural source of truth, they're just huge. We're not talking about some minor technical tweak here. This is a fundamental shift in how we handle information.
The impact here is way bigger than just compressing files. Because the knowledge is a procedure, it makes AI totally transparent and explainable. We've talked about the huge gains in data efficiency, which leads to digital sustainability. And get this, it enables what the group calls zero-effort accessibility. Think about that, one single source that can be turned into text, or audio, or even output for a braille display, with no extra coding needed.
And I just have to come back to the sustainability point because the numbers are staggering. The models are projecting that by reducing all this waste from data duplication and unnecessary computation, we could see a cumulative savings of 12 gigatons of CO2 by 2035. That is a planetary scale impact, plain and simple.
And really, it all comes back to one of the most powerful and frankly beautiful ideas in this whole project, the dual client contract. Here's how it works. There is only one canonical source of truth. One. Humans interact with it through readable text or visuals or audio. And AI systems? They interact with the exact same source as executable logic. There's no secret, second truth hidden away for the AI to misinterpret or get wrong. It's all right there. One source for everyone.
And that really leaves us with the ultimate question to chew on, doesn't it? Just think about it. What would it mean for our digital world, for our trust in technology, for our entire future, if humans and AI could finally, and provably, share the exact same source of truth?